Good afternoon, Robert Scribbler. It is August 13th, 2018. Thank you for joining me for another climate change and clean energy video blog. Now for this segment, I'm going to talk about some pretty extreme warming that we are seeing in the Arctic edge zone and over parts of the ocean near Siberia, particularly in the Laptev Sea and in the East Siberian Sea region. And presently, it appears that surface temperatures over the Laptev Sea and over this section of Arctic Ocean related waters is in the range of 16 degrees Celsius or about 60 degrees Fahrenheit. Now, these temperatures are much warmer than normal at present. I'm going to go ahead and show you a surface temperature anomaly map provided by Climate Reanalyzer. It's based on the GFS model. And here in this region, we were just looking at surface temperatures in the range of 10 to 15 degrees Celsius for this time of year. Now, Arctic temperature departures during summertime tend to moderate as the energy shifts more toward melting ice and as the ocean effect tends to moderate temperatures. And this is in relationship to typical Arctic temperature anomalies as we would tend to see them as a signature of polar amplification related to fossil fuel burning and human-caused climate change. During the wintertime, we tend to see the Arctic Ocean region heat up considerably compared to past years. But in the summertime, we tend to see a moderation. So these much warmer than normal temperatures over water during summertime, even in the closer to the continental edge zone region, is pretty intense. It's a pretty intense anomaly. Now, looking at sea surface temperatures, I just also want to note that the waters in this region are also much warmer than normal. And looking at yesterday's sea surface temperature anomalies, we find that temperatures are well in excess of 4 degrees Celsius above normal at the ocean surface, and this is having an effect both on surface temperatures over these water regions and on sea ice melt in the waters near this warmer than normal region. Now, I just want to call your attention to the fact that over the next few days, these warm temperatures are expected to persist as warm winds funnel up into the high Arctic above the 80-degree north latitude zone and shift toward the East Siberian Sea, where we have a remnant section of sea ice that has been considerably thinned. And I'm going to go ahead and just advance this model so you can see the movement of these warm temperatures. So later today, we see very warm temperatures approaching the coastal areas in central Siberia in the 24 degrees and rising up to 27 degree Celsius range. That's above 80 degrees Fahrenheit, and continuing to intensify as the day progresses and maximum daily heating occurs. Now note that over the next couple of days, the warm temperatures, or the much warmer than normal temperatures, shift closer to the East Siberian Sea region, and we see some rather brisk warm winds rising up off of eastern Siberia and into the East Siberian Sea in association with a complex of low pressure systems in the 985 millibar range. So this warm wind situation is not going to be quite as intense over the sea ice covered region of the East Siberian Sea. Even though sea ice is dispersed, it will tend to have a cooling effect, but these above freezing temperatures will also tend to likely enhance sea ice melt in this zone. So looking at present sea ice concentration, we see quite a lot of thinning in the region associated with the warm water pool and warm air temperatures near the Laptev Sea. And as I said before, the sea ice is rather diffuse in the East Siberian Sea region, and so it's vulnerable to any warm air or warm wind influx. So this will be something to look at over the coming days. Now, looking at the satellite shot, I'm going to go ahead and just run a few days. I'm going to back this up just to August 9th, and I'm going to go ahead and zoom in on this region of the near the Laptev Sea here and getting close to the high Arctic. We are looking at 79 degrees north latitude in this region, and just watch the ice move over the 3-day period here as I advance this model. So I'm just going to back it up again so you can see the ice edge and just receding quite rapidly as warm winds begin to blow in from the south and a low starts to form at the edge of the Laptev Sea in between the Laptev and the Kara Sea region here. So we get some cloud cover occlusion, but rather rapid reduction in sea ice due to a warm wind type scenario. And here's a visual of the thinner sea ice over the East Siberian Sea. And this ice might see some increased melt rate impacts as the warm winds shift toward the east and begin to blow over the East Siberian Sea. So something to look at over the coming days, and just something to keep in mind in regards to the overall context of human-caused climate change as we observe much more rapid changes in the Arctic than in lower latitude regions. So just as a conclusion, I'm going to zoom out here and give you guys a visual shot of the large wildfires that are also burning in the far northern regions of Siberia, producing a very intense smoke plume. And it is notable that increased wildfire activity in the Arctic and in the near Arctic and over permafrost zones is also a signature feature of human-caused climate change. So thank you for joining me, and I'll be chatting with you soon.